Hi class, this is Mrs. Lyons. This is a quick video to show you how to put numbers into scientific notation and also how to take numbers from scientific notation and put them back in standard notation. Scientific notation is a way of writing very big and very small numbers, which we need to do in chemistry since atoms are so very, very small, and when we're talking about them, we're talking about a very large number of them. So before we start looking at how to manipulate numbers, let's just look at a number that's written in scientific notation, 7.6 times 10 to the second. There are some parts of this number that you should be familiar with. The first part of the number is called the base. And the base, when we have a number in scientific notation, is always going to be between 1 and 10. Okay? And when we say it's between 1 and 10, what that is doing is it's giving us one non-zero digit before the decimal. Okay? And the other part of the number that we need to know about is the exponent. Okay, so the 10 to the 2 power. If the exponent is positive, like in this case we have a positive 2, that means we're dealing with a big number. Okay, usually a very big number, but definitely a number bigger than 1. If that exponent is negative, that means that we're dealing with a smaller number, a decimal number, and that number is going to be less than 1 and greater than 0. So let's look at how we put these numbers into scientific notation, or how we convert them out of scientific notation. So here we have two numbers, 1.2 times 10 to the 4th and 3.4 times 10 to the negative 3rd. We want to write these numbers in standard notation, in other words, without the exponent. So what we do is we look at the base. Since this is a 4, that means that this number is going to be positive, or it's going to be a big number. That means that we're going to move the decimal to the right. Okay, so if we've got 1.2 times 10 to the 4th, we want to move this decimal 4 places to the right. So 1, 2, 3, 4. And everywhere where I've put a little loop, I'm going to add a 0. So this number in standard notation is going to be 12,000. Now, when we see a number that has a negative exponent, that means we're going to move the decimal to the left. And in this case, negative 3, we're going to move the decimal 3 places to the left. So if I write this number 3.4, I need to move the decimal 1, 2, 3 places to the left. And again, I'm going to fill those little loops in with zeros. So my number written in standard notation is going to be 0.0034. Okay? Now, what about putting big numbers or small numbers into scientific notation? So we have the number 345,000. When we do this, it's important to look at where the decimal is and where we want the decimal to end up. Okay, so when we have a number without a decimal in it, we don't always write the decimal, but it's assumed that the decimal is right at the end. Okay? Now, what we want to do is we want to get this number, the base of this number, so that there's just one number, the 3, before the decimal. So when we get done writing this in scientific notation, we want to have 3.45. All right? Now, how many places do we have to move that decimal to get this to be 3.45? So let's count. 1, 2, 3, 4, 5 places. Which that means that our exponent is going to be a 5. Now, since this is a big number, a number bigger than 1, the exponent is going to be a positive 5. So we've got 3.45 times 10 to the 5th. When we deal with very small numbers with decimals in the front, we kind of go about it the same way. We need to look at this number and we need to write it with one digit, in this case the 4, before the decimal. So 4.6 is going to be our base. Then we have to figure out how many places we need to move the decimal to get this to be 4.6. So we look 1, 2, 3, 4 places. So we're going to write 4.6 times 10. Since this number is a very small number, our exponent's going to be 0, so it's going to be -4. Okay, so 4.6 times 10 to the -4th. Last one, 2900. Again, we don't have a decimal, but we assume that the decimal is at the end of the number. So to put this into scientific notation, our base is going to be 2.9. Okay, how many places do we need to move the decimal? 1, 2, 3 places. So we're going to have 2.9 times 10 to the third. It's a positive number because the number is bigger than 1. I hope this video has helped a little bit in your understanding of scientific notation. I will see you in class.